In this module, let us study about the properties of inverse trigonometric functions. Let us quickly revise what we have learnt so far. If sine inverse x is equal to y, then sine y is equal to x. Also, sine of sine inverse of x is equal to x, where x belongs to a closed interval, -1, 1. Similarly, sine inverse of sine x is also equal to x, where x belongs to a closed interval, -π/2, π/2. You also learnt about inverse trigonometric functions and their principal value branches. Let us now prove some properties of inverse trigonometric functions. The first property states that sine inverse of 1/x is equal to cosecant inverse x. Also, cos inverse of 1/x is equal to secant inverse x. Similarly, tan inverse of 1/x is equal to cot inverse x. Now, let us prove that tan inverse of 1/x is equal to cot inverse of x. Denote cot inverse x by y, which implies that x is equal to cot y, or 1/x is equal to tan y. This further implies that y is equal to tan inverse of 1/x. Finally, substituting the value of y proves the result. Similarly, the remaining two properties can also be proved. The second property states that sine inverse of -x is equal to minus sine inverse x. Tan inverse of -x is equal to minus tan inverse x. And cosecant inverse of -x is equal to minus cosecant inverse x. Consider the second part. Let us denote tan inverse of -x by y. This implies tan y is equal to minus x. It can also be written as x is equal to minus tan y, or x is equal to tan of minus y. Now, tan inverse of x is equal to tan inverse of tan of minus y. This implies tan inverse of x is equal to minus y. Since tan inverse of tan theta is equal to theta, substituting the value of y gives tan inverse x is equal to minus tan inverse of minus x. On multiplying both the sides by -1 gives the result, that is, tan inverse of minus x is equal to minus of tan inverse x. The other two properties can be proved in a similar way. The third property states that cos inverse of -x is equal to pi minus cos inverse x. Similarly, secant inverse of -x is equal to pi minus secant inverse x. Also, cot inverse of -x is equal to pi minus cot inverse x. Let us prove the first part. Cos inverse of -x is equal to pi minus cos inverse x. Let us assume cos inverse of -x is equal to y. This implies cos y is equal to minus x, or x is equal to minus cos y. Further, minus cos y can be written as cos of pi minus y. Since cos pi minus theta is equal to minus cos theta. This can also be written as cos inverse x is equal to pi minus y. Substituting the value of y, we get cos inverse x is equal to pi minus cos inverse of minus x, or cos inverse of minus x is equal to pi minus cos inverse of x. In a similar manner, the remaining two properties can also be proved. The fourth property states that sin inverse x plus cos inverse x is equal to pi upon 2. Also, tan inverse x plus cot inverse x is equal to pi upon 2. Similarly, cosecant inverse x plus secant inverse x is equal to pi upon 2. Let us prove tan inverse x plus cot inverse x is equal to pi upon 2. X is equal to tan y. Now, tan y is cot of pi upon 2 minus y. This implies x is equal to cot of pi by 2 minus y. Taking cot inverse on both the sides, we get cot inverse x is equal to pi upon 2 minus y, which can be written as cot inverse x plus y is equal to pi upon 2. Substituting the value of y, we get cot inverse x plus tan inverse x is equal to pi upon 2. The other two properties can be proved in a similar way. The fifth property states that tan inverse x plus tan inverse y is equal to tan inverse of x plus y upon 1 minus xy, and tan inverse x minus tan inverse y is equal to tan inverse of x minus y upon 1 plus xy. Let's prove the first property. Denote tan inverse x by a and tan inverse y by b. This implies tan a is equal to x and tan b is equal to y. Now, tan of a plus b is equal to tan a plus tan b upon 1 minus tan a into tan b. Substituting the values of tan a equal to x and tan b equal to y in the equation, we get tan of a plus b is equal to x plus y upon 1 minus xy. This implies tan inverse of x plus y upon 1 minus xy is equal to a plus b. Substituting the values of a and b, we get tan inverse of x plus y upon 1 minus xy is equal to tan inverse x plus tan inverse y. The other property can be proved by following the same method. The sixth property states that 2 tan inverse x is equal to sin inverse of 2x upon 1 plus x square. Also, 2 tan inverse x is equal to cos inverse of 1 minus x square upon 1 plus x square. And 2 tan inverse x is equal to tan inverse of 2x upon 1 minus x square. Let's prove the first one. Let us assume that tan inverse x is equal to y. This implies x is equal to tan y. Consider the right-hand side. Sin inverse of 2x upon 1 plus x square. Substituting tan y in place of x, we get the right-hand side as sine inverse of sine 2y. This is because 2 tan theta upon 1 plus tan square theta is equal to sine 2 theta. This is further equal to 2y or 2 tan inverse x, which is the left-hand side. Hence the result. In the same way, the other two properties can be proved.